The no choice theorem ends up being really handy, and of course it makes such sense. Look at these two triangles. In the first triangle, triangle ABC, we have already used up 130 degrees. So how many degrees do we have left over? 50. And in the big triangle, we've already used up 130 degrees. Not a surprise because these angles are congruent. So it was easy to do that sum. And then I know that the amount that must be left over is 50 degrees. So the no choice theorem is sort of a like obvious theorem, but it says that if two angles of one triangle are congruent to two angles of another triangle, then the third angles must also be congruent. And I would definitely write that in your list of postulates and theorems. So I would definitely just copy that right over in your list of postulates and theorems. So let's just use that. So in this number 3, we're given angle A is congruent to angle C. That's our given. And we're going to try to prove angle B congruent to angle D by the no choice theorem. And again, the no choice theorem always has two pairs of congruent angles in a pair of triangles. So we need another pair of angles. Well, always look for vertical angles. So what we can say is we have to name this by 3 letters. Angle AEB is also congruent to angle CED. And that is because they're vertical angles. That's the vertical angle theorem. That's the vertical angle theorem. And then by the no choice theorem, we can conclude that B and D are congruent.